Good day everyone, we are Group 9. So our topic is all about descriptive measure of central tendency, group and ungrouped data. So, what is measure of central tendency? It is an average occurs regularly in our daily life and it is an important tool in statistics. A well-chosen average consists of a single number about which a given data are centered. There can be several different types of average or sometimes called measure of central tendency. They are the mean, median, and mode. So, let's start by mean. Mean is the most commonly used measured data of central tendency. When we speak of average, we always refer to the mean. Again, when we speak of average, we always refer to the mean. And also, mean is found by adding the values of data and dividing by the total number of values. So, when we solve by population mean, we have the formula mu equals summation of x over capital N. And if we solve for the sample mean, we have x bar equals summation of x over short letter n. So, there is no difference in the formula in solving for the population mean and sample mean. N is the total number of observation in the population. That's capital N. And short letter n is the total number of observation in sample mean. So, let us take this example for ungrouped data. A researcher collects data on the ages of recipients of doctoral degree in science and engineering and his study yields the following: 37, 37, 24, 28, 43, 44, 36, 41, 33, 27. So, determine the average of the recipients. Since the given example is for ungrouped data, we're going to use the formula x bar equals notation of x over short letter n. That means we are looking for the sample mean. We're going to add all the data given, so we have 37 plus 37 plus 24 plus 28 plus 43 plus 44 plus 36 plus 41 plus 33 plus 27 equals 350. So divided by 10 equals 35. Therefore, the average of the recipients is 35.
For group data, the midpoints of the classes are used for the values of the x. Group mean. The following are the steps in solving for the mean of group data. Number 1. Find the midpoint for each class. Place them in a column. Number 2. Multiply the frequency by the midpoint for each class. Place them in another column. Number 3. Find the sum of resulting column in step 2. Number 4. Divide the sum obtained in step 3 by the total number of frequencies, that is mean. F stand for the frequency and X stand sub. M stand for the midpoint of each class. 80 randomly selected light bulbs were tested to determine their lifetime in hours. The following frequency distribution was obtained. Find the mean. Nowadays, that we're given with class boundaries and frequencies, so once the data are grouped, that means we are looking or solving for the population mean. You solve for the midpoints in each class boundary. So we're going to add another column for the midpoint. To solve for the midpoint, we have the formula lower class boundary plus upper class boundary divided by 2. So we have 52.5 plus 63.5 divided by 2. We have the midpoint for each class boundaries 52.5 to 63.5. Equal to if day 8, and then do the same for the remaining classes. For the second step, multiply the frequency at the midpoint in each class boundary. So we have 6 times 58. We now have our fourth column, 'The product of our frequency and midpoint. Multiplying 6 by 58, we have 348, and do the same for the remaining classes. The third step is find the sum of the second and fourth column. That is, we're going to add all our frequencies, the product of our frequency and midpoint. We have 80 and 6,807 respectively. By substituting in the given formula, we have 6,807 divided by 80. The mean is 85.09.
Median. The median is the midpoint of the data array. Before finding its value, the data must be arranged in order from least to greatest or vice versa. The median will either be a specific value or will fall between two values. If there is an odd amount of numbers, the median value is the middlemost number with the same amount of numbers below and above. If there is an even amount of numbers in the list, the middle pair must be determined, added together, and divided by 2 to find the median value. The median can be used to determine an approximate average. Example 3. Ungrouped data. 7 months old were selected and given a blood pressure check. Their systolic pressure were recorded below. 135, 121, 119, 116, 130, 121, and 131. To find their median, arrange it from least to greatest or vice versa. Here, in an arrange method, 116, 119, 121, 121, 130, 131, and 135. We can see it in the middle that 121 is the median. This is how we get the group median. Make a table of cumulative frequency. Divide n number of frequency by 2 to get halfway point. Locate the median class in the cumulative frequency column. Substitute in the formula below. Where n is sum of frequency, CF is cumulative frequency of the class preceding or before the median class. F is frequency of the median class. W is the class width. LMD is the lower boundary of the median class.
Example number 4. The record of 32 people in a 100-meter race is summarized in the given frequency table. Determine the median of given data. So we're given with time in seconds and frequency. First step is make a table of cumulative frequency or less than cumulative frequency. So we are going to take 2 as a starting point. Add it by 7, we have 9. Then add 8, so we have 17. And then add 4, so we have 21. Second step is divide n, the number of frequency, by 2 to get the halfway point. We have n over 2, then our n is equal to 21. Divided by 2, we have the halfway point equal, which is 10.5. Third step is locate the median class in the cumulative frequency column. Remember that our halfway point is 10.5. Looking at the less than cumulative column, we can see that 10.5 lies with 8 and 17. The interval that corresponds to 17 is the interval 61 to 65. Therefore, the median class is the interval 61 to 65. The last step is substitute in the formula given. We have to take note that n is the sum of our frequencies. CF, the cumulative frequency of the class preceding or before the median class. F, frequency of the median class. W for the class width, and L sub MD, the lower boundary of the median class. By looking at the table, we have n equal to 21. Since the total number of frequencies is 21, for CF, which is the cumulative frequency before the median class, we have to remember that our median class is 61 to 65, with 17 as the cumulative frequency. So the cumulative frequency before 17 is 9. Our CF is equal to 9 and our F, frequency of the median class. So the frequency of our median class is 8 and for W is 5. Since the interval in each classes is 5 and the L sub MD is 60.5, we can solve this by subtracting 0.5 to 61 by substituting in the formula. We have the median approximately equal to 61.44.
So let's talk about mode.
The measure of average is the mode. It is the value that occurs most often in the data set. A data can have more than one or none at all. The mode for group data is the modal class. The modal class is the class with the largest frequency. The mode is the only measure of central tendency that can be used in finding the most typical case when the data are nominal or categorical. So, mode for ungrouped data. To find the mode for an ungrouped data, we need to find the frequency of each number, value, or observation in the given data set. Then we need to choose the number, value, or observation having the highest frequency as the mode. So to solve for the mode of group data, we just need to substitute it in the given formula, where L sub MO is the lower boundary of the modal class. W is the class width. D sub 1 is the difference of the frequency of the modal class and the class preceding it. D sub 2 is the difference of the frequency of the modal class and the class succeeding it. So let us take this example. To find the mode of the given data set, first is we have to arrange the data set in ascending or descending order to find the mode. Next is we have to determine the number that appeared the most number of times.
Example number 6. So let us try solving for the mode of data. The record of 21 people in 100-meter race is summarized in the given frequency table. Determine the mode of given data. Again, with the game of our median, we're given a time, seconds, and frequency. Example number 1. Identify the modal class by determining the interval, the highest frequency. We have 61 to 65 since it has a frequency and it's the highest frequency among the classes. Example number 2. Determine the exact lower limit of the modal class. To do this, we just have to subtract 0.5 to the lower boundary of the modal class. That is 61 minus 0.5 is 60.5. For example number 3, substitute the formula. Our L sub MO is 60.5, W is 5D sub 1 is 8, subtracted by 7 is 1, and D sub 2 is subtracted by 4 is 4. Adding D sub 1 and D sub 2, we have 1 plus 4 is 5. By substituting the formula, we now have our mode equal to 61.5 and this falls between our modal class 61 to 65. Thank you.